Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P0685, indicates a potential issue with the A fuel sensor 1 heater power source circuit. This sensor is crucial for measuring the air-fuel mixture, helping to optimize engine performance and reduce emissions. Located in the exhaust system, Sensor 1 plays a vital role in ensuring the engine runs efficiently. A malfunction in its heating element can lead to incorrect readings and ultimately impact engine performance. Understanding DTCs like P0685 is essential for effective troubleshooting and maintenance of your Honda Civic. To resolve this issue, it's necessary to follow a structured diagnostic approach as outlined in the troubleshooting process. The DTC P0685 specifically points out an issue with the A4 sensor 1 heater power source circuit deemed open. The A4 sensor, located in the exhaust system, is responsible for detecting the air-fuel mixture before it enters the catalytic converter. The heater within this sensor ensures it operates at optimal efficiency, especially during cold start conditions. When this DTC is set, it suggests that the heater circuit may be interrupted, causing the sensor to fail in providing accurate data to the powertrain control module, PCM. The PCM relies heavily on this information to manage fuel injection and maintain emissions controls. Promptly addressing this error is critical to restoring the vehicle's performance. Understanding the potential causes of DTC P0685 is crucial for effective troubleshooting. Poor connections, either at the AF sensor, the relay circuit board, or the PCM, can lead to circuit interruptions. A faulty relay circuit board may impede the electrical flow needed for the AF sensor's operation. Moreover, damaged wiring could create open circuits, leading to the same DTC being triggered. Additionally, a blown fuse, specifically fuse number A9, can also interrupt the power supply to the sensor's heater. It is essential to systematically evaluate each potential cause to effectively resolve the issue and restore the vehicle's functionality. Drivers may experience several symptoms when facing DTC P0685. A prominent indicator is the check engine light being illuminated on the dashboard, signaling that there's an issue needing attention. Poor fuel economy is another symptom, as an inaccurate air-fuel mixture can cause the engine to use more fuel than necessary. Increased emissions may also be detected, which could lead to failure during inspections of emission standards. Moreover, rough engine performance, such as unusual idling or hesitation during acceleration, may also be noted. Recognizing these symptoms early can aid in preventing more extensive damage and costly repairs. The first step in troubleshooting DTC P0685 involves verifying the issue with the Honda Diagnostics System, HDS. Start by turning the vehicle to the on mode without starting the engine. This initial step allows the system to access necessary diagnostic data. Next, clear any existing DTCs using the HDS. This action ensures that if the DTC reappears, it indicates a persistent problem rather than a transient error. After clearing the DTCs, start the engine. Following this, check for any pending or confirmed DTCs with the HDS once more. If DTC P0685 is indicated, it confirms the failure and mandates further steps in the troubleshooting process. Moving to Step 2, it's crucial to check fuse number A9, which is rated at 15A and located in the underhood fuse/relay box. Begin by turning the vehicle to the off or lock mode to ensure safety and prevent any potential electrical shocks or shorts during inspection. This fuse is responsible for supplying power to the A/F sensor heater. If the fuse is found to be intact, you will proceed to the next step in the troubleshooting process. However, if the fuse is blown, it indicates a potential short circuit in the wiring. In this case, it's essential to repair the short circuit and replace the blown fuse before continuing with further diagnostics. In this step, you'll need to remove the relay circuit board to assess its functionality. This board plays a critical role in managing the electrical supply to the AF sensor. Once removed, carry out a thorough test of this board to ensure it is operating correctly. If the relay circuit board shows signs of failure, it must be replaced to restore proper electrical flow to the AF sensor. Should the relay circuit board test as functional, you can confidently proceed to the next troubleshooting step. Ensuring this component is working properly is essential for diagnosing the root cause of the DTC accurately. Step 4 involves conducting a voltage check between specific test points while ensuring the vehicle is in the off or lock mode. Begin by measuring the voltage between test points 1 and 2. Test point 1 connects to the relay circuit board connector, female terminal number 14, while test point 2 connects to a reliable body ground. The relay circuit board must be removed for this test to isolate the circuit. If battery voltage is detected, it confirms that the +B dBW wire is functional, allowing you to proceed to the next step. Conversely, no voltage indicates an open circuit in the +B dBW wire, necessitating repair of this wire between the relay circuit board and the A9 fuse. In the 5th troubleshooting step, disconnect the 6P connector from the AF sensor to facilitate the continuity check. Ensure that the vehicle remains in the off or lock mode during this procedure. Measure continuity between test point 1, which connects to relay circuit board connector female terminal number 1, and test point 2, which is connected to the AF sensor 6P female terminal number 2. This check determines if the FI sub Rully out IGPS LAF wire is intact. If continuity is confirmed, it indicates that the wire is functioning correctly, allowing you to move on to the next troubleshooting step. Conversely, lacking continuity suggests an open circuit requiring repair between the relay circuit board and the AF sensor. The final troubleshooting step involves checking continuity while taking additional precautions. First, jump the SCS line using the HDS and wait for over a minute. Following that, disconnect the PCM connector number 1, which houses 96 pins to facilitate the test. With the vehicle still in the off or lock mode, and both the relay circuit board and AF sensor 6P connector disconnected, check for continuity between test points 1 and 2. Test point 1 connects to the AF sensor 6P female terminal number 5, while test point 2 connects to PCM connector number 1, terminal number 16. Successful continuity here indicates that the AFHT wire is in good condition, allowing for the possibility of substituting a known good PCM if necessary. If continuity fails, repair any damage in the AFHT wire found between PCM connector number 1 and the AF sensor. After completing all repairs related to DTC P0685, it's essential to verify the effectiveness of those repairs. Start by clearing any DTCs in the system using the HDS to ensure that no stored errors impede the vehicle's diagnostics. Follow this by conducting a test drive under various conditions to allow the system to assess engine performance accurately. After the test drive, check once more with the HDS for any reoccurrence of DTC P0685 or other related codes. If the DTC does not return, it indicates a successful resolution of the issue, confirming that the components and connections have been properly restored to operational status. To prevent the occurrence of DTC P0685 in the future, It is essential to implement routine maintenance for your Honda Civic. Regular system checks are crucial for identifying potential issues before they escalate. Specifically, consistently inspect the wiring and connectors for signs of wear or corrosion, which could lead to circuit interruptions. Moreover, monitoring the condition of fuses, particularly the 15A fuse number A9, will help identify electrical issues early on. Implementing these preventive measures ensures reliable operation of the AF sensor and contributes to the longevity of the vehicle's performance and emission control systems. In summary, diagnosing and addressing DTC P0685 is essential for maintaining the performance and efficiency of your Honda Civic. The AF sensor plays a significant role in emissions control and fuel management, making its functionality critical. Following a structured troubleshooting approach ensures that the underlying cause of the DTC is identified and resolved effectively. Additionally, implementing preventive maintenance measures can help avoid similar issues in the future. Understanding DTCs and conducting timely repairs not only prolongs the vehicle's lifespan, but also enhances driving experience and adherence to emission standards. Please like and subscribe to the channel. See you next time.